Okay, so yesterday I promised you guys that we would be totally done with that really long limit as h approaches 0 thing except for the multiple choice. And so today we're going to kind of look at the shortcuts for finding the derivatives of different function types. So first of all, we're going to consider just a constant function. So something like f of x equals 3. Right, so if we were going to graph f of x equals 3, it's like y equals 3. Right, we would just graph a horizontal line at 3. And so I want us to think, what does the tangent line to this graph look like? Well, the tangent line is actually the graph itself, right? Like if we were going to draw a tangent line, we would just be drawing a line like kind of anywhere. If I was going to draw this tangent line, we'd just be drawing the line over the top of it. So it is itself. And what about the slope of that graph? Right, the slope of any horizontal line is just 0. So kind of based on this process, right, we know that f prime of x, that is the slope of the tangent line. And this entire graph has a slope of 0. So it's always f prime of 0. So this is going to kind of come up with a rule that's, basically anywhere if f of x equals c, then the slope is 0. So if we said f of x is 4, then we know that the slope is 0. If we said f of x is 2, we know the derivative is 0. If we said f of x is negative 64, then f prime of x, the slope is 0. So for any constant, this is kind of a rule, for any f of x equals c, then f prime of x equals 0. Okay. So we know that the constant of the derivative of any constant is 0. Okay, now I'm going to go through 6 of these, and I want you guys to try to see if you can start to see a pattern. I know we're not in class, but just kind of see if you can see a pattern. So I'm going to just kind of do them. I'm not going to explain how I'm doing them. I just want you to look at the function and the derivative and see if you start to see any patterns. So maybe you're starting to see a pattern or two. These last two are a little bit weird. Um, but, for this one, I'm going to just write it with the negative exponents. But just be aware that you could rewrite this as 2 over x squared minus 6 over x cubed, right? Because the negative exponents can move down. So just kind of make sure we're aware of that. Okay, so I'm hoping you guys saw some patterns. I'm going to kind of explain how I did this, and maybe you already have seen the pattern. But I took the exponent, so the squared, I multiplied it down, so 2 times 3 is 6x, and then we just subtracted 1 off of the exponent, so 6x to the first power. Minus, now here I kind of did the same thing, it's the first power, so 2 times 1 is 2x to the 0th power, but we know anything to the 0th power is just 1, so we can kind of just get rid of that because 2 times 1 is 2. Here, kind of same thing. Oh, by the way, what about the 3, right? The 3 goes away. Why does the 3 go away? Because we said that the derivative of any constant was 0. And one thing you could kind of show with that, technically it's x to the 0th power, and 0 times 3 is 0. So that's why this goes to 0. Okay, so this time 3 times negative 5, negative 15x squared, subtract off 1. 2 times 2 is plus 4x to the first, and then minus 3. So kind of another pattern you'll start to see is that anytime we have the derivative of something with just an x, it just becomes that number. Here, same thing, the 6, the derivative, that's going to go to 0. So negative 9x squared plus 24x cubed, right? We're multiplying down, subtracting off 1. Here, same process, negative 1 times negative 2 is positive 2. But now when I subtract 1, we get x to the negative 2nd power, right? And then same thing, this will be minus, right? Because negative 2 times 3 is minus 6, x to the subtract 1, negative 3. So we're always subtracting it. Here when we multiply down, 2/3 times 6, right? The 2 times 6 is 12 over 3 becomes 4x. And when you subtract 1, you can kind of remember this pattern. Anytime you're subtracting with fractions, you're subtracting 1, you're just going to subtract the denominator, right? Because 1 is going to become 3 over 3. So really all you have to worry about is subtracting the numerator from the denominator. So 2 minus 3 is negative 1/3. And minus 8x subtract 1 to the negative 3. So again, I'm going to kind of talk about that process. So first we're going to multiply. Negative half times 6 is positive 3. But just subtract the denominator, like the numerator minus the denominator. So it's going to be negative 1 minus 2 is going to become negative 3 halves. And here when we multiply we get 3 halves. And then 1 minus 2 is going to be negative 1. Okay. So this rule is going to be called the power rule. Okay, underline this, highlight this. But the power rule for derivatives or for differentiation. Right? When we see the word differentiation, that means kind of the process of taking the derivative. So now, instead of having to do that long whole limit as h approaches 0, which is the actual definition, the power rule is a shortcut. And it tells us that, now, this is a new symbol. So this means the derivative. So this means the derivative of. The derivative of, essentially, something. So in this case, it's x to the nth. And we're going to say with respect to x. So we're going to learn later on that we can take derivatives with respect to x, but we can also do with other variables. So kind of the D part is showing that we're going to take the derivative of something. And then this bottom part is the telling us what variable we're using. So this is the with respect to x. So in this case, in this box is the x to the nth power. So that's the notation. That's kind of how we read that. So essentially, kind of what we used to write was we used to write f prime of x. Right, that's one notation for a derivative, and essentially d, well, f, would be in the box would go at y. So dy dx can be written also meaning the same thing. So these are going to be the same. We're going to kind of realize that. But for right now, just kind of understand that this here is telling us that we're going to take the derivative of x to the nth power. So our power rule is going to be that we're going to take our exponent, we're going to multiply it to the front. So we're going to have n times x to the nth minus 1, right? Because then we're going to subtract off 1 from our exponent. So in order to be able to use the power rule, we need the equation to be written as a polynomial. Okay, so it always has to be written as a polynomial. So kind of what a polynomial is whenever we have the sum or difference of multiple monomials, right? So essentially, f of x has to kind of look something like this: ax to the nth power plus bx, to say the n minus 1, or some other, we could call it mth power to another power, plus dot dot dot. Eventually at the very end you could have like a constant, a c, but that's a monomial, or sorry, a polynomial. So here this is not written as a polynomial. So these are some examples where we don't have a polynomial. So what we're going to kind of do is we're going to do two steps if it's not a polynomial. Our first step is going to be to rewrite it as a polynomial. And then our second step is going to be to apply the power rule. So in this first example, right, we're going to first rewrite this as f of x equals, now what do we know if we have a x in the denominator? We can bring that up and change it to a negative exponent. So 2x to the negative second minus 4x cubed. So this was just rewriting it. I didn't take the derivative yet. And now we're going to take the derivative with power rule. So now we're going to multiply negative 2 times 2 is negative 4, x to the negative third, and minus 3 times 4 is 12x squared, right? We subtract off 1. Now, on a multiple choice free response, you can box this. This is a perfect answer. But on a multiple choice, they might just bring the x cubed back to the denominator, right, and make that exponent positive again. Next one I'll do on the right. So first step is going to be to rewrite this. So it's not a monomial, but we do know that we can always separate from the numerator, right? This is something we learned last chapter. So 3x to the fourth over x minus 3x squared over x minus 2x over x. We could do that. Or if you had seen, that's one way to do it. Another way to do it would be to factor out an x. So to kind of write x times 3x cubed minus 3x minus 2 all over x, and then cancel out the x. Or you could have just realized, hey, there's an x everywhere, and I can cancel out 1x. So I'm going to kind of do that. But regardless, what you should get when you rewrite this is you should get to 3x cubed minus 3x minus 2, something like that. Okay, and now we're going to apply the power rule. So f prime of x is going to become 9x squared, right? Multiply the 3 times the 3, subtract 1, minus 3, right? Anything with an x, the derivative just goes to the number, and then the 2, the derivative goes to 0. So there's our derivative. Okay, and the next one, we're going to need to FOIL this out. So first, I'm going to multiply these two, and that gives us x squared plus 2x plus 3x plus 6, all times 2x plus 1. So that's x squared plus 5x plus 6 times 2x plus 1. And now we need to multiply these. You can do the box method if you guys are good with the box method, but I like the method that I kind of showed you guys yesterday in class, which is x squared plus 5x plus 6 times 2x plus 1. And so I really like to multiply like this. So 1 times 6 is 6, 1 times 5x is 5x, 1 times x squared is x squared. Then 2x times 6 is 12x. I'm going to put it with the x. 2x times 5x is 10x squared. And then 2x times x squared is 2x cubed. And then we're just going to add those up. I'll kind of write this off to the side. So we get 2x cubed plus 12x squared plus 17x plus 6. And so now this is just f of x. This is not f prime of x, right? This is just f of x. So we're going to write f of x is equal to 2x cubed plus, I messed that up. This was not 12. 1 plus 10 is 11x squared. So plus 11x squared plus 17x plus 6. And then now that we've done that, now we will apply the power rule. F prime of x equals 6x squared plus 22x plus 17. So there's our derivative. Okay, the next one, we can again factor out an x squared from everywhere. But we're going to notice that even if I take out an x squared from everywhere, that's going to become x, this is going to become x cubed, we still get x minus 5 over x cubed. So this is where we do need to split up. So anytime we have an adding or subtracting in the numerator, we can always split up. So we can rewrite this as f of x equals x divided by x cubed minus 5 divided by x cubed. And here we can cancel out one more x. So I'm going to put a 1 here, make this squared. So we get f of x still equals 1 over x squared minus 5 over x cubed. But we need this as a polynomial, so we're going to need to bring up the x terms in the denominator and turn them to a negative exponent. So that was just rewriting it. Now we're going to take the derivative. So negative 2x to the negative third plus 15x to the negative fourth. And the last step would just be to kind of rewrite it the way it was before. So negative 2 over x cubed plus 15 over x to the fourth. Generally, you want your answers to have only positive exponents. Okay, now this next one is definitely tricky. But this is something that we learned in the review unit that we absolutely have to know. And that's that if I ever see something written like this, the cube root of x squared, that's x to the 2/3 power. It's a fraction. So the inside exponent always goes in the numerator, and the outside exponent always goes in the denominator. Now, what if there isn't, what if it's something like this, x cubed? Well, there's kind of an imaginary 2 here, right? Because it's a square root. So this would be x to the 3/2, right? The inside goes in the numerator. So anyways, in this one, what we can do is we can use this to help us. And we're going to rewrite this as f of x equals 3x divided by x to the 2/3 power. Now, this is a little bit weird, but we can cancel out an x to the 2/3 power. So this is kind of strange, but if you remember really, kind of far back with your exponent rules is if we had something like x cubed over x squared, we cancel out an x, but the reason for that is that really this is like having x to the 3 minus 2, right? Just like how when you have f of x equals x squared times x cubed, this is like x to the 5th, but it's because it's x to the 2 plus 3. So here, really what you're doing is you're subtracting off 2/3. So this is x to the first power, but instead of writing it to the first power, we could write it as to the 3/3 power. And so what's going to happen is that, we can take away 2/3. So we're subtracting off 2/3. So when we rewrite this, it becomes f of x equals 3x to the 1/3 power. So it's kind of weird. But we're just rewriting that, right? We have not taken the derivative yet. So now when we go in and we take the derivative, we multiply the 1/3 down, and we get f prime of x equals 1/3 times 3 is 1. X to the, now we're going to subtract, when basically we're subtracting 1, but that's like subtracting 3 over 3. So x to the negative 2/3. Now I'm going to rewrite this. This is 1 over x to the positive 2/3. And this is a perfectly fine answer. But if we want to rewrite it in radical form, this would be 1 over. Now, the denominator goes on the outside. The numerator goes on the inside. So 1 over the cube root of x squared. Okay, I know this is new for some of us. So maybe, play back that part of the video and rewatch it one more time. But we are going to do one more example that has to do with these, but they're as fractions. So we don't have to rewrite the radical. So in this one, first step is going to be to take the 3/4, and multiply by 4. So f prime of x equals 3/4 times negative 4 is negative 3x. And the shortcut, right, we're subtracting 1, which is 4 over 4. But the shortcut is just to kind of subtract the denominator from the numerator, so to the negative 1/4. Then plus 1/4 times 2 becomes 1/2. X to the 1 minus 4 is negative 3/4. Now, we never want to have negative exponents in our answer. So negative 3 over x to the 1/4 plus 1 over 2x to the 3/4, right? This goes to the denominator, there's a 2 there. So that's a perfectly fine answer. If you really wanted to put this in radical form, this would be the 4th root of x plus 1 over 2 times the 4th root of x cubed, and that could be your answer. I generally just kind of leave it the way that the question was written. So in this case, if the question was written with fractions, right here our question is written as fractions, then I leave my question written with fractions. Whereas in the previous example, our question was written with a radical, so I prefer here to write mine with a radical. But really just check the answer keys that I provide in class and try to get it to that answer. Or if it's multiple choice, then you'll kind of have an idea. So that's our basic power rule. I'm going to kind of split this up. So we're going to stop here and we're going to learn about sine and cosine in a second video.